Hey there, student math students. Welcome to classwork homework 8.2, random sampling. Remember to write down your score for the Edpuzzle video right here. Counts as classwork grade. I will grade your homework. All right. So for sampling, everyone in a population must have an equal chance of being selected in order for a sample to be random. So let me give you some examples. So if you put everyone's name in a hat and then selected one at random, that would be a random sample. Everybody has an equal chance to have their name pulled, right? Pick a number at random. Every number has an equal chance because there's no repeats in the number. These are used, random samples are used for fairness and usually, possibly, to represent a larger population. So let's read the situation here and then determine if the various methods would produce a random sample. All right, so it says, the senior class president would like to host an after-graduation lock-in. There will be games, gifts, and food. In order to decide if people will be willing to buy tickets and attend, she has decided to conduct a survey. She will select 25 students to meet and give input into the prizes, food, and ticket prices. There are 500 members in the senior class. So which method should she use to select these 25 students in order for it to be random? All right. Method number 1. She selects every 10th student as they get off the bus one morning. Now think carefully. Is that random? No, it is not random. Reason why it's not random is that she's only surveying bus riders. So there could be people that walk. There could be people who get dropped off by their parents. What about their input, right? Number 2, she asks her choir director to allow her to survey the choir. This is also not random, right? Pretty straightforward logic here. She's only surveying the choir members, right? Hasn't talked about any other clubs, any other people that maybe aren't involved in the choir, all right? Method number 3, she makes an announcement that people interested could meet in the library after school to participate. Now that seems like it's kind of random, right? Nope, this is also not random because here you're only getting volunteers, right? Just asking people if you want to participate. Some people will be like, nah, I don't want to waste my time with that. And only the volunteers are actually going to participate. So still not representative of all 500 members if we want a truly random sample. All right. Number 4, she meets with the counselor who selects every 20th student on the school roster. This is absolutely random. It takes into account every single member of the senior class, 500, and it does every 20th, right? That's a random assessment. Number 5, she assigns each senior a number and randomly selects 25. Of course, this is random. In fact, it even has the word random in there, right? Randomly selecting 25 numbers, right? And lastly, a roster of the senior class is printed and each student's name is put into a hat and the participant selects 25 names. That is exactly like one of the examples I gave you, right? So that is also random. So the key here for you to understand is that in order for something to truly be random, you go back to this point, everyone in the population must have an equal chance of being. Now, why would we use samples in the first place? We can use samples to tell us information about the entire population. Maybe it's not possible for us to take a survey of the entire population. If we use a correct random sample, what we get out of that random sample, we could then extrapolate or predict out what it might be for the entire population. So let's take a look at this video company. It says a video company randomly selected 100 of its subscribers and asked them how many hours of shows they watch per week. Of those surveyed, 35 watch more than 10 hours per week. So based on that data, if the company actually has 3,000 subscribers, how many would watch more than 10 hours a week? So it's taking this random sampling of 100 people and saying, okay, if I can understand that 35 out of 100 watch more than 10 hours of TV, how do I figure out how many out of 3,000 would do that? And it's kind of like setting up proportions like we used to. So you have this proportion that's percent over 100 equals part over whole. You could also write it out like this. Your sample part over your sample whole is going to be equal to your entire part over your entire whole. So if you take a look at this one, your sample part was 35 people who watched over 10 hours of television. Out of how many people did you sample? 100. And that's going to be equal to your entire part, which is what you're trying to figure out, over your entire whole, which is all your subscribers, right, out of 3,000. So we can change that question mark into our good old friend the variable x, and then we just cross multiply and solve. So 35 times 3,000 equals 105,000, and 100 times x equals 100x. So one-step equation where I see multiplication, so therefore I just divide both sides by 100 to solve, and x is equal to 1,050. So out of 3,000 subscribers, 1,050 of them would go ahead and watch more than 10 hours of TV. All right, we can do this on a whole bunch of different levels. So number 7, it says based on the data collected from a random sample of 80 students, right? So that's your entire sample whole, or sorry, that's your sample whole, not your entire whole, regarding their elective. If the entire school, that right there is your entire whole, has 400 students, then what is a reasonable estimate for the number of students who prefer music? So you're only looking at this music space right here, right? So let's go ahead and write what we're comparing. So we've got the sample breakdown, those who like music in the sample and all the people in the sample, and then we got the entire school who likes music and the entire school population. So let's go ahead and plug those numbers in. In the sample, we had 14 like music out of 80 students that we surveyed. 14 out of 80 is equal to, we don't know how many in the entire school like music, but we do know that there are 400 students. So let's just go ahead and cross multiply. 14 times 400 gives you 5,600. 80 times x gives you 80x. And again, we got ourselves a one-step equation. I see multiplication, so therefore I just divide both sides by 80. Right? Cancels out. X is going to tell us how many students in the school actually like music. And our answer is 70, right? 5,600 divided by 80 is 70 students. That makes more sense because if I had only a sample of 80 students and 14 of them like music, well, if I increase the number of students, more students should like music, right? I want you to try number 8 and 9 in partners. So for homework, you're going to use this data set right here based on this story. The Mitchell Junior High School newsletter staff conducted 2 samples. Here's sample 1, here's sample 2, in which 40 students, you'll notice that these both total up to 40, so you don't have to worry about that, randomly selected to represent an entire 600 student population. Help them determine which headlines are accurate representations of data. So they're just saying, hey, based on these samples, can we write these headlines? So over 300 students want to start after 8 a.m. So start time after 8 a.m. would be all these guys, the 8:30 folks and the 9 o'clock. So let's write out their proportion. So for sample 1, the guys that want to start after 8 o'clock, that's 18 and 10. That's 28 out of the 40 surveyed is equal to x over, remember there were 600 students in the entire population. And then for sample 2, right, that's the 19 plus 7, so that's 26 students want to start after 8 out of the 40 surveyed, so that's x equals to x over 600. You're going to cross multiply and solve and see if that is a true statement. So again, basically you're going to want to say, of these headlines, using these proportions, do you get true statements, right? And then the second section below is a little bit, you want to give an example of a random sample and a sample that is not random for those events right there. That's it. Call me if you have questions.